Good afternoon, all. On behalf of IoT Academy, we welcome you all for the fourth session of National Level Faculty Development Program on the fundamentals of research and research methodology. Let me introduce the resource person of today's session, Dr. Ashok Kumar Patnaik. Dr. Ashok Kumar Patnaik is currently working as Associate Professor and Head, Marketing and General Management, Institute of Insurance and Risk Management, Hyderabad. He has got more than 23 years of experience in teaching. He had received his PhD in Business Administration from Utkal University and had qualified UGC NET exam and received a black belt in Lean Six Sigma. He has co-edited books and published articles in international journals like the International Journal of Financial Research, the International Journal of Economics, Commerce and Management UK, and Global J of Arts and Management. He has attended and conducted numerous FDPs for faculty members and management professionals. We welcome you, sir. And with this, we hand over the session to Dr. Ashok Kumar. Sir, please.
Good afternoon, all, and thank you, ma'am, for your brief introduction to me. I hope this session will be useful for all the researchers and all the people who are attending this program. Though data analysis is a very vast area, and covering that entire topic within 1 hour is a very Herculean task. But I'll try to do my part, and I'll try to do the basic things, because many researchers feel that whenever you talk about very statistical things in the beginning, they get disheartened and they feel they develop a negative attitude towards the research and data analysis. So to start with, I'll just start with the basic, and slowly we'll progress towards the difficult part. And at the end, I'll try to give you a mantra, we can say, or a formula which will help you to find out the adequate statistical tool which you can use for your research. All the questions you can reserve till the end of the session so that we can progress. But unless it is bothering you so much, then you can ask me, and I'll try to clarify it. So data analysis is a process for obtaining raw data and subsequently converting it into information useful for decision making by users, and data collected and analyzed to answer the questions. Also, it is used to test the hypothesis or prove or disapprove some kind of theories related to different subjects or areas. So with that, we start the data analysis topic today. And generally, I always start my program with some kind of pictures. Here, my colleagues, ex-colleagues who are present here, they must be, they can be relating it to their experience with me, my lectures. So here, like data analysis and interpretation, we can say that it's like kind of the picture which you are seeing. Data is raw data is a kind of ingredients, and they expect you to come up with some kind of finished dish or finished recipe. So this is the entire journey which you will be taking care or taking off during the data analysis and interpretation process, converting the raw material into finished products, and then that presentation part will be taken care by the report or the presenter who is going to present this thing. So this data analysis, there is a myth among many of the researchers that the data analysis will start only after the data is collected and the data gathered or collected, and then only this activity will start. That is not the truth. Actually, the truth is that your job starts the moment the research topic is decided. And once the research topic is decided, then the objectives are set. And the objectives, based on the objectives, the hypothesis is set. And based on the hypothesis, then again you start developing the questions. And the questions, again, when you are designing the questions or the research designing, there you have to keep in mind the data analysis aspect in mind. Otherwise, what will happen? All your efforts will be like you gather something which is of no use, and the person who is going to do analysis, he'll be, he'll be carried away with all the data which is irrelevant, or which he will not be able to establish a connection between them. So generally, the data processing or the data analysis starts with when you develop the questionnaire, and that during that questionnaire only you have to intervene and try to see that there are no double barrel questions, or there are no questions which are irrelevant, because one question which comes up for analysis without its relevance to the study will be only just wastage of time. So you have to cross check, you have to go through the questions and see that all these questions are relevant, and that data which is obtained from this question by using that question can be useful to you, or you should be able to analyze that data. Otherwise, collecting the data which you cannot analyze is of no meaning, right? So you start with editing of data, and these are the 5 different steps. We'll discuss all of them in detail, which we also call as data reduction, because a lot of piles of data will come to you. You have to pick up the right one for your analysis. Otherwise, the old saying that goes like garbage in, garbage out. So if you put in garbage in your analysis, garbage report will only come up. So you have to select the right data, which will give you the right answer or right report. So first you start with editing of data, and then you go for coding of data, then classification of data, then tabulation of data, then last you do interpretation or summarization. This is generally followed by some people, but some other people also do some kind of translation after coding. Like if you have collected information in dual languages or in other foreign language, or you have done it in a regional language or something, the translation aspect also comes into play. Some people misunderstand data analysis with translation or transcribing, but that is not correct. So translation is just a process of converting the data into readable format, which the researcher or which the analyst can understand. Otherwise, it will be a foreign language for him, right? So this is the thing. I have shown 2 different slides, so you can see that translation is not to be misunderstood with the analysis aspect. So data processing primarily involves editing or coding of data and tabulation of data. These 3 things, basically data processing we call it, and it helps you to create some kind of form of tables or graphs, so that the analyst can interpret some meaning or derive some meaning from that. So first step in that is editing of data. So when you get the field questionnaires from the field or from the respondents, you need to find out what is happening or what has happened with these questionnaires. Sometimes what happens, some people may not have filled some questions, or sometimes some people have not given the answer in a logical sequence, like or they must have tried to script in or put in biases into that. So you need to correct them, and some kind of omissions are there. Some people have left it, then you have to send it back to the field to collect it or correct it. Or if there is a possibility also, you need to also do the editing on behalf of the respondents. So you need to check the legibility, whether that person is eligible to answer that questionnaire or not. Suppose somebody does not have a vehicle, and you are doing a study on automobile ownership of say executive bank employees. So in that case, if that guy is not having a vehicle, but he's answering the questions relating to a vehicle, or somebody is not married, but he's answering the the concerns relating to children. So in that case, it is going to lead to biasness. So you have to find out whether he's eligible, or the eligibility or the legibility of the data, and completeness, whether they have filled all the questions or not. Because if some questions are not filled, then that is going to impact your entire analysis. You cannot take a half-filled questionnaire. Similarly, consistency, as I have told you, and some places he says, yes, I own a house. Then he says, no, I am staying in a rented house. then there is an inconsistency. Some places he says, yes, I am employed and I am drawing salary, and some places he says, yes, I am also taking the unemployment allowance from the government. So, these things you need to check out from your questionnaire when you are doing the editing of data. So check the consistency and the responses, and also you need to take care of the editing. As I told you, you can send it to the field if it is possible. Otherwise, you have a central editing team which can be located in the headquarters where you are doing analysis, and you can do the editing. So in editing, you have three options when you are doing a missing value or something. So you can take the minimum value, or you can take the maximum value based on the average, or you can take an average. Or sometimes if you are in a stage, that respondent, or you can identify the respondent's the value which he's supposed to write there, then you are at the liberty to put in that one. But that is generally discouraged by the researchers. So editing, as I told you, you can do if you are not satisfied with some kind of resume. So how you can handle that? Like one is you can return to the field, and then you can also assign missing values, which I told you, minimum, maximum, or some kind of average you can write down there, and you can fill that form. Otherwise, if you feel that it is not at all possible for entirely filling that questionnaire, and it is very difficult to replace the values which the original respondent would have given, in that case, what you can do is you can discard that questionnaire, and you can take the others which are completely filled up for your analysis. So this is how this editing is done. And as I told you, you can deduce the answer by inspecting other answers, sometimes of the same respondent, or you can deduce the answer by inspecting answers from other respondents, similar respondents. Suppose you are talking about middle level managers and their purchase ability or purchase capability. So if what others are doing, you can judge from that and you can put it. Or you can return, like I told you, but don't encourage the data, or don't leave the data dirty. That means if it is unfilled, or if it is messy, or if it is wrong data, don't allow it. Like I told you, garbage in, garbage out concept will be applicable. If you allow some kind of wrong data, wrong information to get into the further processing of the information, which we call as analysis. So the analysis is nothing but we try to spot something useful when we see or what we can see from the data. That is what we call as analysis. So analysis concerns the identification of meaningful patterns of the data. Generally, you try to see a pattern, maybe it's increasing, decreasing, or it's stable. What is happening with the data? You can try to find a trend. So generally, we call it a trend, or you can say pattern from the data. And that is the main purpose of doing the analysis. But some people, they get confused with the interpretation, and they try to use, they generally use interchangeably this interpretation with analysis. So I would like to bring in that difference between these two. Like if you see, analysis is where the researcher limits and comments to the facts discovered through the study. Whatever the study is saying, you only focus on that in analysis. You don't try to bring in your own prejudice, or you don't try to bring in your own concepts or own learning or own experience or own views into the analysis. Whatever is high, you say high. Whatever is low, you say low. If it is something which is negative, you say negative. If it is something positive, you say positive. You don't comment on that, why it is negative or positive in analysis. But when you say interpretation includes the personal expertise, the expert who is working in that field or certain area, or the researcher. He brings in his own ideas and speculations that are not necessarily confined or conformed by the data collected. So that may relate to the data collected or that may not relate. So he can oppose or he can support based on his own expertise on this data. Like if there is a share price is increasing, so he can suggest or he can say, okay, this share price is increasing because of these three factors. Maybe there is a fall in the currency value or exchange rate, or maybe there is a there is a slowdown in terms of economy, or there is some kind of social or political unrest in the country. So that is the reason. So he is bringing in that concept. When you bring in these own ideas, concepts, speculations, and relate it or publish it with that analysis, that is called as interpretation. Otherwise, interpretation just deals with data. It says only what the data is saying. The picture of data only talks. It is not going to talk something from its own or from the researcher's perspective. So interpretation, as I told you, refers to the task of drawing conclusion from the collected facts after an analytical and experimental study. So you try to draw conclusion. In analysis, you don't draw conclusion, you just state whatever it is. You just narrate the present condition. You just explain the present condition. But when you talk about interpretation, you try to reach to a conclusion. What is happening? Why it is happening? How it has happened? Or who is responsible for this? So you try to answer all these questions, and you try to reach to a conclusion or a reason why this thing is happening, or what is making it possible, or what is stopping it. So you try to reach to a conclusion through interpretation. And interpretation is the act of explaining, as I told you, and reframing, or otherwise showing your own understanding of something. You as a researcher or you as an expert, you try to understand, or you try to find out or give your opinion on what is happening, what is the reason behind this development or slowdown, or the activity, how it is progressing or not progressing. Based on that, you try to bring in your own concepts or your own understanding. That is known as interpretation. Now we go to the techniques for analyzing data. So data analyzing techniques can be categorized into different variables. Many researchers do have different levels, but I will say we can divide it into two different levels. First one is the lower level, where you just try to find out the research objective. Whatever the research objective is you have set, you try to find out that, or you try to limit it to that thing. Like the techniques which are used is like summarizing. Summarizing is like keeping or bringing in all things together, and to measure the different dispersion of data. And also you try to do some kind of cross tabulation of the data. I will try to explain that a little later. And the other level of analyzing data is higher level. Higher level includes the hypothesis testing and drawing an inference from the sample data. You try to find out what more you can understand from this thing. What we call as reading in between lines is what you try to attempt here. And the most important thing is you try to prove your hypothesis. Hypotheses are kind of statements which you give based on the nature of the data, based on after studying the data or after studying the situation. I'll come to that a little later also. So the function of data analysis, as I have shown here, you can see that like summarizing of data will lead to some kind of statement like this, like the average age of respondents is this much, or the average income of the respondents is this much. So that will tell you there are so many different age students or employees of different ages, but it will give you a particular statement, like it will summarize in one line, or it will summarize in a standard statement, or a one-liner statement, which will give you a proper understanding of the entire population. Like here, it says that the average age or average income of respondents is 23 years or 25 years or 5,000 rupees or 10,000 rupees. Similarly, applies understandable conceptualization. So you also try to understand the conceptualize. Like the example is, few respondents are younger than 25 years. So if the average age is that, but it also tries to tell you that few respondents are younger than 25 years. So it also tries to make you understand a concept or a group which is existing. Similarly, communicate underlying patterns. So it also tells you different types of patterns which is existing in that data. Like most satisfied customers recommend our brand, or most dissatisfied customers, they go to competitor's product, or they buy competitor X product or Y product, or X is our most fierce competitor. So it also communicates some kind of pattern which is emerging, or which is prevailing in that situation. Also generalizing sample findings to the population. And this means that, like good example is, this means 70 to 80% of the target market is liking our product or buying our product, like this kind of statements. So this is how this data analysis tries to bring in some kind of learning or things which help you in taking a decision. Like if you know the average income of respondent is this much, then you can change your pricing, or you can design a product which is matching to their income group. Or similarly, if you know that your this age group of customers are very few, then you can target a niche, you can make a niche product for them or something like that, right? So you reach to this conclusion, like I told you before, like to identify or understand the factors that determine the preferences for Times of India among the readers. Why Times of India is preferred. So similarly, to identify the profile of the readers of the Times of India, and again to ascertain the expectations versus perceptual reality, and locate gaps, if any, amongst the readers of the Times of India, and to analyze the factors responsible for the most preferred subjects of information attracting the readers of Times of India. So these are some kind of outcomes of the analysis. Now we go to the coding of data. Like I told you, coding is a very essential element of before you start your proper analysis. So coding of data is essential because you will have a lot of information, and that information, putting them into a sheet or putting them into computer for further analysis is a very cumbersome task, and coding helps you in that. And coding provides you a solution for data entry. Otherwise, what will happen? There are so many different factors, like we already know that qualitative, quantitative factors, and putting them into numbers or this thing is very difficult. Coding, in fact, helps you to convert that qualitative aspects into quantitative aspects, like putting them with a number. So it's a process of converting qualitative data into quantitative data by translating response choice of questionnaires into numerical values. So it helps you to convert the qualitative data, which generally is very difficult to capture. Then it converts them into numerical value. And in coding, numbers are also associated to qualitative attributes, and variables facilitate data entry and analysis. So when you put the numbers, it becomes very much easy for you to enter the data. Coding also allows the researchers to reduce large quantities of information into easily handleable form. When you have only few numbers, it is easy to key in, instead of writing that strongly agree, strongly disagree, strongly agree, strongly disagree. Every time you write, it is very difficult. But if you give them a coding 0110, it becomes very easy. Then we come to the types of coding. So there are different types of coding. Generally, coding is done in two ways. One is the pre-coding. So pre-coding is the process of assigning codes before going to the field. Before you take your questionnaire to the field for data collection, you do the coding itself. And what you do is you take the questionnaire, you construct a coding sheet, and you send them to the field for collection of the data. Otherwise, if you have not done that, then you can also do the post coding. So post coding is sometimes it is done because you don't know what kind of, if you have many open-ended questions, in that case, questions how these respondents are going to answer, you don't know. So you cannot do pre-coding for these open-ended questions. So in that case, what you do is you wait for the questionnaires to arrive from the field, and then you do the post coding. So this process is called as post coding. Here you do the complete data after the completion of the data collection process, you do the coding. So these are the two types of coding process which is used before we go to the analysis. I give you some examples here. You can see some questions are here, like which newspaper you read. So somebody asked to the respondent, he has given some options: the Times of India, the Hindustan Times, or the Indian Express, the Pioneer, or any other like that. So here, if you try to enter that thing, all the newspaper without coding the names, it will be very lengthy and it will be very difficult to again summarize what is happening, who is reading what. It will become very difficult. So as a researcher, what you need to do is you need to give a coding. Like you can see here, Times of India will be given 1, and if somebody is choosing Times of India, he will be given 1 in his in the calculation. And if he's choosing other papers like HT, then HT will be given 1, and other papers will be given, other options will be given 0. So this is how it can be done. Otherwise, you can also give 1, 2, 3, 4 also. Like the second question we can see here, like I have been subscribing UI for how many days? Less than 6 months, 6 months to 1 year, 1 year to 2 years, 2 years to or more. So this you can give 10001, or you can also give, like here you can see 1, 2, 3, 4. Like if somebody is saying I have been subscribing to Times of India less than 6 months, you can say 1. And if he chooses the second option, 6 to 12 months, then you can choose 2. And if he chooses third option, 12 to 24, you can give him 3. Otherwise, you can also make this, like if you give one option 1, if it is selected, other options 0, and you can go on like that. So this is how you can do coding for all your questionnaires. You can see here some other questions are there, like how would you rank? Ranking also you can give coding 1, 2, 3, 4. You can see here, like each one ranking you can give 1 to 5, or similarly the other questions also you can do coding. Coding will help you to input the data into computers, and it will become very easy for you to do the analysis. Coding, I'll show you this one. This is how this coding sheet will look like. Like if you can see here, question number 1 had 5 options. So 1, 2, 3, 4, 5. So if he has chosen Times of India and some other paper, so there you will be giving 1, 1, and you give 0 to others. Similarly, question 2 has 2 options, 1, 2, and if he has chosen like male, female, so male is 1, female is 2, so he has chosen female, so you write 2, right? And similarly, other options are there. So wherever there are many options, you can choose 1, 2, 3, 4, 5, or you can choose 0, 1, 0, 0, 0, like that. So at the end, you can summarize the total, that how many numbers are there, and you can divide that by number of respondents. That will give you the percentage. If you, I'll show you that little after that, maybe little later. So then what you do is you go for tabulation, go for like kind of, sometimes what happens, data is also available in terms of like what this sheet you can see is like class intervals are there, and tally numbers or frequencies will be there. So if you are doing it manually, this is how you can do. You suppose 6 is there, you draw 4 lines, and the 5th line will be a cross, and the 6th line will be again standalone. Suppose there are 9, so 5, and there are 4. Suppose there are 13, so 5, 5, 10, and another 3. So you don't make a mistake here. Otherwise, what will happen if you count like that, you will make a mistake. So this is how manually people used to do. But nowadays, all these computers are doing it. But you should also know the basics when it is how it is done, right? When you try to plot it on a graph paper or do it manually, you use these methods. So tabulation of data is also a very essential element here. And after editing, coding, and classification is like you divide the data into the different groups. Suppose you have done 4 different experiments. So experiment 1, experiment 2, experiment 3, or experiment 4, you can do that. Or you have collected it from different locations, geographical locations. Say you have collected from Tamil Nadu, you have collected from Andhra Pradesh, you have collected from West Bengal, you have collected from UP. So you don't want to mix up the data. So you can classify them based on the geographical location. Similarly, age group or gender, you can classify the data for your further study. Again, it depends on the study, what is your objective and what is the purpose of the study. So, but if there is a requirement for classification, you do that before you do the analysis. Otherwise, you will be into trouble because all the data will again pile up and you will be finding it very difficult to compile them. Then tabulation is systematic. Generally, you do the tabulation, which is tabular form and basically non-statistical thing. And it is a systematic and logical presentation of data in rows and columns to facilitate the comparison and the conduct of statistical analysis. And tables can be prepared manually or by computers. Generally, tables can be prepared both manually and computer. And tables can be best performed with the help of statistical softwares by using different analysis. I'll show you some tables little later in my last part of this thing. But tables generally you can prepare manually or in terms of you can take the help of software packages also. And surveys analysis involving large number of respondents and cross tabulations have 2 variables, and it is very time consuming to do manually. So generally people take the help of computers. So cross-sectional tables, which we generally call as contingency tables, where you try to match 2 variables or try to match 2 variables to draw some kind of conclusion or some kind of analysis, right? So generally they look like a rectangular shape, like here. Like in one side you have all the variables like food, clothing, education, house rent, miscellaneous expenditures. So he's talking about expenditures, and here he has taken 2 families, family A, family B. So the amount which they have spent, they can either be in terms of money or it can be in terms of the percentage. So this is called as 2-dimensional tables or 2-dimensional cross-sectional tables, contingency tables also some people call it, cross 2-dimensional diagrams also some people call it. This is how you can also represent the data. So for tables, these things are very essential. There should be a title, there should be a column heading, and there should be a stub, and there should be some kind of supplementary notes to make them understand what is it. Is it expenditure or is it income or is it saving? What is that? Then you should have a body where the amount of the figures are written. So this is generally the prerequisite for the analysis if you are presenting that in terms of a table. Now we go to the graphical representation of data analysis. Here we are starting the analysis part. So after all these things, the first thing, there are 2 ways you can represent your data. One is the statistical data analysis and the other one is graphical data analysis. First, we'll talk about the easy one, which is graphical data analysis or graphical representation of data. So generally, you get the data in 2 ways. One is non-frequency data, where there will be no range, or there will be no highest number, lowest number, or minimum value, maximum value. So those data we call as non-frequency data. And there are also frequency data where there will be a range like 15 to 25 years or 5,000 to 10,000, or there will be some kind of upper value and the upper limit or lower limit. In that case, you use frequency data tools. Like non-frequency data, you have pictograms, bar, line graph, pie, square chart, or qubit. And for frequency data, you use histogram, frequency curve, frequency polygon, ogives, and box plot. Generally, these are used by the researcher to showcase their data analysis or to present their data in this thing. Pictograms are like, use of simple pictures to represent the data. Like you take the picture of human beings or motorbikes or animals or kind of other products, cattle, or other like some kind of, suppose you are talking about some kind of soft drink, then you take a soft drink bottle. You are talking about some kind of furniture, then you take the picture of a furniture to give the number. This is generally done for depicting or talking about the numbers. Like you can see here, how many students are affected or enrolled in different universities across the world. Suppose somebody wants to talk about that, and so he can represent these pictures in terms of number. This is just an example. So he's presenting that in terms of a pictorial graph where one student sitting is equal to 1 million. One picture is equal to 1 million. So you can count like that. Here it is, the first one is showing 7 million and the last one is showing about 9 million. So this is how you can represent the graphs or the data in terms of pictographs. Good example of this one is you must have seen in TV when they compare the ammunitions, army power, or the arms and ammunitions of different countries. Like India, how many they have, and how many they have in China, like nuclear helicopters or tanks or armed vehicles or naval fleets or fighter jets or attack aircrafts, submarines. So they are showing it in terms of a picture. So these are known as pictographs. So this is one kind of analysis also in terms of telling the numbers or something. What you do is you try to depict that or you try to showcase that in terms of a picture. Then comes the pie chart. Pie chart, most of us are using it. Uses a 360-degree round or to represent the different different parts or shares of a product or of a expense or of income or something like that. Like here you can see how much is the spending done by one person on different heads like food, education, rent, clothing, saving, etc. is shown in a pie chart. So this can also be represented through different colors. I have brought it in black and white, but you can show it different colors. Then comes another popular chart. We call it square pie chart, which is generally used by many companies to showcase their data. It is very easy to understand and very quickly people can understand or realize what is happening with the data. The data can be easily understood. So different squares, like you can say this mess, how many percentage of men and how many percentage of women are there, and what is their strength. You can see from this color. So color one, blue ones are women, and brown ones or gray ones are men. So different products which are sold also can be listed down. Even you can list out your KPI, key performance indicator of your organization, how much you have achieved in quarter 1, quarter 2, quarter 3. You can also list them in different square pie charts. So this is also used as a tool to showcase the data in terms of analysis. Then you have some qubit charts. These are used specifically when they want to relate 4 or 5 or 6 or even to some extent even more number of factors or more number of points. Like here they are adding time. They want to relate time with location, with the items or products. So this uses generally 3D data cubes where different items are linked to each other, and you can link to each other and try to see that their relevance or their impact on each other. And this is called as qubit charts. Generally, these are used in companies or production units to show the data. Then we have histograms, the popular ones. Here you try to take the x-axis, the frequencies, and y-axis will be the result, right? So here you can take this. This is the easiest one, which everyone is using, histograms. Same histograms, when you add the middle points with straight lines, they become the polygon, frequency polygon we call them. And if you use the free hand, then they are called as frequency curve. If you use a free hand to draw these points, then that is called as frequency curve. But if you draw a straight line with these center points of this frequency points, then it is called as a frequency polygon. So this is also used by many of the researchers to show their analysis. Then we have line graphs, as you have seen that when you add the points together and draw match link it to each other, that is called as line graph. These line graphs are generally used for comparison, to show some kind of comparison with two different cities, two different products, which is a very useful thing for the researchers when they want to do some kind of comparison between the values or between the various points or the the results. So this is called as line graph. This is also used to showcase or analyze the data which has been received from the field. Ogive frequency curve, as I have told you, here you need to bring out the cumulative frequency of the frequencies, and you need to add them. Like you can see here, 12 is added to 18, that becomes 30. 30 is added to 35, that becomes 65, like that. And those points you try to plot on a same like frequency curve type. And here, then you get a point which we call it ogive point, and here you try to see that whether points are falling above, is there any outlier or not. If there is an outlier, you need to think about it and you need to focus on that. Outliers are something which is extraordinary, which is not falling in this category. Then you have another popular box plot, Turkey box plot. This is now popularly used by many researchers nowadays because everybody is using histogram and all. So now many people are using this Turkey box plot. This has actually 5 different variables, 5 different measurements. Like you can see here: minimum, quartile 1, median, quartile 3, and maximum. So you can see some values in the maximum and minimum, and in between there is a box. So where that point or that value is coming, we try to check that. And if it is in the middle, it is called as normal. And if it is down, then it is called as positive skewed. And if it is up, it is called as negative skewed. And that is how you compare different experiments. Suppose you have 4 experiments or 5 experiments. Here you can see like this graph is showing 5 different experiments. So now you see in this 5 experiment, where is that point which is coming? And you can see some 2 dots are there in the third box, which is the outlier. We call them as outlier. Means they are out of your maximum level or out of your minimum level. In point 1, you can see chart 1 in point 1 figure. You can see one dot is below. So that is like it has come to the below the minimum. So somewhere it is maximum, minimum. Then you need to take care of that or find out the reason why it is happening. The popular one is scattered plot diagram. Generally, you try to plot all the values in terms of a scattered line, and you try to see that whether they are closely related or not. Here you can see some outliers will be there. Like we can say that we are taking the average income of all Indians. In that, maybe that Adani and Ambani, maybe they will be the outliers because they will not fall within the category. It will be somewhere beyond. Or maybe somebody who is a beggar. We cannot say now these beggars are more richer than other people. So you can say somebody who is a jobless person, whose income is very less. You can say his also income is average income is below the scattered line, or it is a outlier. So these are the ways and means through which you can show the graphical analysis. Now we go to the statistical analysis aspect. So here, the criteria, like before you get into statistical analysis, you must understand, or you must think, what is the purpose of the analysis? If it is only to describe, it is only to come up with a point to study the data, then it's okay. No need for statistical analysis. But you want to reach to a conclusion, you need to prove, you need to develop a theory, you need to prove or disprove something. Then you can employ the statistical tools and techniques, because otherwise it will just increase your efforts, and at the end you will be just frustrated, because the statistical things are very cumbersome, and sometimes you need to take help of others, experts, to reach to a conclusion. And many people who are not good in statistics, or who are first-time researchers, they find it very difficult to continue further, because statistical things will, drain out your all energy, because it requires a lot of involvement. So the type of measurement skill also need to be found out. You need to study the old literature, what kind of scale they have used. Based on that, many people use dichotomous scale. Why? Yes, no. I generally don't recommend my scholars to use that, because that is not going to give you any meaning. So you try to use Likert scale, and also there are so many other scales are there, based on the previous research, what previous researcher has used, or what the similar researchers are using. You try to find out that, and the number of samples also need to be increased. Like many people get into research just by doing 10-20 samples. So minimum 30 to 100, or maybe more than 100 to 100 if you take large samples, then statistical tools employing will be beneficial for you. If you are doing with a small sample, better to stay with these graphical descriptive samples, descriptive statistics. Otherwise, if you really want to do a good job, then take a large sample. Large sample statistical tools will help you, and the number of variables also to be analyzed. So variables, we are not getting into dependent on these things. I think researchers are familiar with that. So there are different tools which are used by researchers, different types of analysis tools. When we talk about statistical analysis, one is descriptive analysis. It is used to describe the sample data metrics in such a way that to portray the typical respondents, and to reveal the general pattern of response. So what is the response respondents are saying? Just general pattern you want to reveal. So some earlier data is there, some information is there. You just want to prolong, you just want to describe it, like this it's saying descriptive analysis. So here the tools which you generally use is mean, median, mode, frequency, distribution, range, and standard use. Simple tools generally you use for descriptive analysis. The aim is to just try to find out what the respondent is trying to showcase, or what the respondent is giving or saying about the topic. Then inferential analysis, as I had already told you before also, like when the statistical procedures are used by the researcher to generalize the result. Like here you are taking some kind of sample, and you try to generalize the result to the population. Generally, descriptive studies are more related to population only. So they do this, like entire class you study, but here you take some sample. So when you are doing inferential statistics, then you are trying to take a sample, because you cannot read the entire population, but you take a some small group of sample, and you try to derive the meaning from that, and use it for the entire population. So here you are using some kind of hypothesis, and you also get to know about the standard errors. I'll be talking that after 2 slides. So difference analysis is also one. It is used to determine the degree to which the real and um, to the real and the generalizable differences exist in the population in order to help the manager to make enlighten the decisions on which the advertising themes use. Like mostly this is used for advertisements and marketing things. So here you can take the example of p-taste or analysis of variance, etc. So associative analysis, it is used to determine the systematic relationship among the variables, and it investigates if there is if any two variables are related or not. Here you are doing the tools like correlation and cross tabulations. As I was telling you, descriptive statistics generally you use the population, whereas the inferential statistics you try to take a sample and you try to generalize the findings on the population. And descriptive, the data is generally known to you, but inferential statistics you try to derive a conclusion from the data. Also, the final result is probability scores is based on the probability scores in the inferential statistics, whereas the descriptive statistics generally the final result emerges in terms of tables or graphs. So as I told you here, in descriptive statistics generally you use mean, mode, median, and spread of data for range and standard deviation, whereas in inferential statistics generally you use tools like hypothesis testing, analysis of variance, etc. So also there is another type of analysis which is used by researchers, which is called as predictive analysis. It helps to make the predictions or forecasting. Here, like the regression analysis, you try to develop models which will help you to predict some kind of result or the what is going to happen if situations change or if there is a change in one variable to the other variable. So here you are using the regression analysis. This is called as predictive analysis. You try to forecast or you try to predict about the future events. So it's like kind of model development. So there are different scales, as I have already discussed: nominal, ordinal, and interval. So nominal scale is there. Then you have to use mode and frequency distribution. Suppose the ordinal scale is there, which is used for collecting data, then you use median. Interval scale is here, where there is the range. You try to use mean and variance, standard deviation, coefficient, and variation. This is the way you should use for data analysis. Then there are errors. As I told you, many errors come into the analysis. When you are doing the analysis, you come across many kinds of errors. So first one is improper definition or problem. If problem is not properly defined, what is to be studied, what areas you need to focus on, then purpose of the study is not properly defined, then you come across an error. Like you are not sure how the study will go on and what direction you have to take. Then sometimes what is that the specific information is being required by the researcher. So, but the researcher has not received this information. So, in that case, again, it is very difficult for the analyst to match to the research objectives, and there again that error comes in. Again, one more is poorly designed questionnaires lead to ambiguous questions, like the questions which has, as I told you before, has no meaning or no relationship with the research. In that case, again, improper responses, putting them in the analysis will lead to some kind of errors. That is called as designing error, designing research questionnaire designing or collection errors, what we call. Then deciding on the sample type. Similarly, sample, if it is not properly measured, there is a technique of a sampling technique, which I'll tell you if I get to time in some other session or something. If the sample is not properly selected or there is not adequate number of sample, again, that leads to biases and possible errors. Then also errors come in because of fluctuation or association associated with sampling. I already told you. And there is improper selection of respondents. or inexperienced interviews also sometimes play a big role in leading to errors, sources of errors. So errors generally what happens, they impact on the raw data which has been collected in terms of questionnaire, and it again is reflected in the processing and analyzing and reporting of the research. Hypothesis, as I told you, if you are doing a qualitative research, then you are bound to have hypothesis, because you need to prove something, and for that you need to create a null hypothesis and a alternative hypothesis. Null hypothesis are the general statements where there is no difference, which are the status quo statements, whereas alternative hypotheses are the different options, or alternative options are the actions which are mentioned as a alternative hypothesis. So here again, two types of errors happen. One is type 1 error, which occurs when the sample results lead to a rejection of null hypothesis, which is in fact true, but it has sample has rejected the hypothesis. That is called a type 1 error. And type 2 error is when the sample results based on the sample results, null hypothesis is not rejected, whereas it is a false statement, right? Like, say, for example, rich people are not kind, or that statement may be wrong, but that statement may be wrong, but our sample has said yes, it is correct. So, or we say that people are not honest. So maybe this kind of statement is not wrong always, but our statement, our research has brought in that this is true. So these are some of the errors which you come across when you are doing the analysis. So you have to take care of this type 1, type 2 errors. And if you are getting that, then again you go back to the data analysis, check the data, check the tables, check the entries, and try to see that where there is the flaw. Then comes the presentation of this data, like not presentation, but analysis of the tables. So when you, I suggest you don't make single tables. When you are collecting some kind of demographic data, try to present it in such a way, like which I am showing you. All the demographic factors or figures, you try to show them in one table, one single table, like gender, age, marital status, number of children, income, or employment status. All this data, you try to present them in a single table, which will make it very easy to understand. And the person who is studying it, the person who is reviewing it, or trying to learn from it, he will find it more comfortable, instead of giving individual tables. Generally, most of the researchers, they do give individual tables when doing analysis. So I'll say you do a single analysis table, which will also help you to when you do the cross analysis table, right? And this is what I suggest. All the demographic factors, all the demographics items, you try to put them in a single table: gender, age, marital status, number of children, income, employment status. All these things you put in one table. Obviously, all this everything will be 100. Gender will be total will be 100%. Percentage, you try to show them in percentage. It will be very easy to understand, or it is very easy to accept the points. Then there are different multivariate tools, analysis tools, chi-square, regression, and all these things. I think you no need to explain about what is chi-square and all. Generally, you can get those statistical points when you are using a SPSS program. Here I have brought a screenshot from the SPSS program. So you have, once you have loaded all the information on the SPSS table, SPSS software, you can just go to analyze, and then you will find descriptive statistics. So here, what you do is you can choose the tools which you want to select. So here it will give you the options, various options, frequencies, descriptive, explore, cost tabs, ratios. So when you do that, you can easily find out some statistical tables which you can generate from the by using this SPSS software. So here I have used this table, this software, and got a chi-square table for one of my studies. This study was related to the distribution of pharmaceutical of healthcare product, health insurance product during the COVID period. This was a study which I published in a book also. So here you can see there are two different hypotheses: null hypothesis and the alternative hypothesis. And the table after that is being generated by the software. So you try to give a heading on the table based on your question which you have asked to the respondents, or it should be based on the hypothesis. Like you can see here, the hypothesis is cost of insurance vis-a-vis the consumer perception on the health insurance policy cross-tabulation. So we are trying to compare the variables cost of insurance with the consumer perception on health insurance. So this is how we have got the table which has been generated from the SPSS. So after this table you receive, you try to explain that. Here some key elements are there. One is the degree of freedom. So you have to mention about the degree of freedom. Like the degree of freedom is 3 or 4, whatever it comes. You try to mention that the degree of freedom indicates the number of independent values that can vary in an analysis without breaking constant. And the most important thing is that the Pearson's chi-square, what is the value? You try to find out the p-value. We generally call it as p-value. P-value you can see here is 0.004. And your rule of thumb says that p-value should be less than 0.05. Right? If it is less than 0.05, then we reject the null hypothesis and we accept the alternative hypothesis. So this is how you can write the analysis or interpret the analysis. So here you can see it has a p-value, and that p-value you need to compare with the industry standard or the significant level, which is the minimum level should be 0.05. And if it is below this, you reject it. If it is above this, you accept it. Similarly, regression model I have said here. I have also brought in an example of regression model. So here this logistic regression model, right, which is going to give us a model like how much alternative assets is on the alternative investment instruments. What is the people's perception? How do they think about alternative investment? Alternative investment is the investment which is like into gold or into real estate or into other forms of investment which is not into pure government stocks and shares, right? So what people want to do, what decision they will take. So based on that, what we have done is we have given some kind of weightages, which you can see x1, x2, x3, x4, xn, so xk like that. So these weightages we have given to different values or this. So and we try to build a model based on that regression model y equal to a plus bx, and you try to explain that, like what are the weightages and what are the options, like what is y, what is x, all these things you try to explain. This is how you go and explain the or you do the interpretation or the data is explained. So again, presentation is a different part, and this is what I was telling you, like when you have the data, you first decide what is your goal, and based on that you have to choose one test, parametric or non-parametric. So you have different tools I have listed here, right? You can choose from them, and based on your goal, like you want to describe one group, then you need to choose mean, standard deviation, mean or current interquartile. And if you want to compare two unpaired group, then you have to go for independent sample test, Mann, Whitney, U-test. These all will get in spaces when you go to analyze and find out from the statistics tools which you need. Similarly, compared to paired test, paired sample t-test, and Wilkerson test, right? So this is how all these things data analysis is done. I hope I could cover up a little bit. There are so many things which are untouched. Uh, Only researchers, when they do work and when they interact with each other in groups, and when they attempt to write new papers, new research articles, then only they'll be able to explore. I'm also still exploring every day one or two new tools, new methods, everything. So I stop my um, discussion here. Thank you.
The session is open for discussion now. You can unmute and interact with the resource person, or you can post the questions in the chat box. Thank you, sir. Thank you all.
Hello, shall I? Hello, sir. It was a very nice, informative session. Shall I ask a doubt?
Yes, ma'am. Please.
Okay, so, sir, we are testing the hypothesis and we are concluding, accepting or rejecting based on the p-value 0.05.
Yes.
So, at the same time, we have learned that if we are doing a test like t-test or f-test, we are checking the alpha values like t alpha, whether it is within or about t alpha or f alpha, like that. So, how it is related with the p value and alpha value? Because suppose in a case, if the result is 1, according to p value, it is more than 0.05, so it's rejected. But if it's within t alpha, it is accepted. So, what is the relation between that?
No, this one is exclusive for hypothesis is exclusive testing you have to do. Hypothesis you cannot again club with a P. P has to be again different variables are there. Here you are only talking about correlation with the particular value or variable in hypothesis. Really, is it hypothesis is accepted or not? Maybe that
Okay, it's a
can
different test.
different test. Yes.
Okay. Huh.
T-test,
Okay,
jet
sir.
test, T-test, jet test, chi-square test, all these things will be little different.
But
Here
with
I'm
that
talking
test
talked about,
only, but with that test only, we are checking whether it is point within 0.05 or not, right, sir?
this is correlation I have done. Other tests are also there. I think we should not get confused with both clubbing.
Okay,
I'm
suppose
only
if we
talking
are
about the error and hypothesis only I have talked about here.
okay, so to know in relation with probability, we have to do some other
Again,
test, and
again
F
some other.
test and T test, we have to do some other test.
Yeah, rat test and t-test will not link with the hypothesis. That will not decide whether hypothesis is to be accepted or not. Chi-square test. I have done here. If you can see this one, this is chi-square test.
Okay, so even for the chi-square in the table, we'll be checking with alpha value, isn't
Yes.
it right, sir?
Yes.
So how it is that chi-square
P-value.
alpha value
P-value.
is related with p-value?
P-value. P-value. It should be p-value, not alpha.
Okay. So P is denoted only for chi-square test.
Yes. This p-value here, this one, alpha is your standard. P-value is the result which you have derived. 0.004 is the p-value.
Okay.
Alpha is the significant level. It should be compared with this p-value. We should not get confused with both. P-value is the result.
Okay.
0.04. It can be 0.087. It can be 0.02 in another study. It can be 0.1 also. It can be higher. It can be lower. It can be anything. But this one is the standard rule of thumb. This
Okay. So
significance
sir,
level, rule of thumb, p-value.
okay. So suppose in any condition, if we are doing a t-test, then that result, how we are comparing?
That I don't have any idea, ma'am. It depends on this research. We need to check everything because we
Huh.
cannot
Okay,
say
sir.
what is the research. We need to check what is the condition, what is the thing.
Okay, sir. Okay, sir. Thank you for your valuable input.
So, what are the methods used by the researchers while data collection?
Data collection, you have so many different methods. So generally, first you can use this. There are two methods. Like one is the questionnaire method is there. Otherwise, you can also use telephonic methods are there, or you can nowadays this focus group or different type of group meeting. You can also conduct some kind of surveys, some kind of discussions and depth interview, what we call. So many interviews, so many different tools are there. It depends on you what type of data or what type of research you are doing. Suppose you are doing something which is related to some kind of specialization activity like economy of India or something which general people cannot answer. In that case, you can have a depth interview or a focus group interview where you call the experts who are working in Indian economy, like a professor or like an economist or like a banker or some kind of somebody who is writing some kind of articles or something or doing something on economy. So you can call these 4 5 people and you can give this topic and you let them deliberate, and then you can take their inputs and collect that information. But if it is a general one, like the perception of customers or something which can be gathered from general public, then in that case, no need for this kind of focus group or in-depth interviews or something. You can go open it to who with a questionnaire, and you can go to people and you can ask them like whoever, like you can do kind of sampling, judgmental sampling or something, and based on your requirement, you can ask the customers or employees. Suppose you are doing a survey on employees, then go to some company and ask the employees. But if you want to only study on the strategic steps or strategic decisions taken by CEOs, then you have to go for an in-depth interview only with the CEO, because that ordinary worker will not be able to give you the insights of strategic decision about the company. So again, it depends on what is the research, what is the objective of the research, all these things. Even also the budget, how much budget you have, what is the time you have. If you are in a hurry to publish this thing, you don't have the luxury to go and talk to everyone. There you can do a telephonic survey by just sitting in your office, talk to 10 people and do a telephonic survey. Or nowadays this internet survey, online surveys are very popular. So it again depends on the volume of the research, what kind of thing, how much money you want to involve, the scope, the length. Do you want to do it in a small city, or you want to spread it into multiple cities? All these things again depend on the type of data, the tools which you are going to use. All these things depend on that.
Any other queries?
Okay, ma'am, you can.
Yes, sir, we shall wind up. On behalf of IoT Academy, we thank Dr. Ashok, sir, for the enlightening and interesting session. We thank you once again for the amazing presentation, sir, and we thank you for enhancing your knowledge with the commendable presentation. We thank you very much for your efforts. It was an amazing and an insightful session, sir. I thank all the participants for joining the session today. Thank you, sir. Thank you very much for your efforts.
Thank you. Namaskar.
Kindly submit the feedback form using the link that has been posted in the chat box. Thank you all. You're welcome, sir.
You can leave now, ma'am.
Yes, sir, you can leave, sir. Thank you very much, sir.